Okay. Hello students. So today I am going to teach you the velocity of approach. So today we are going to discuss the velocity of approach in bit detail. So let me go through it. Let me check it also that it is live or not. Yes, fine. All right, student. Well, so see, you have gone through some questions which is you can solve through the velocity approach concept. And there is a relative velocity also, and relative velocity is quite common, and even you can see most of the questions of JEE Advanced is based on relative velocity. But the velocity approach is also a good concept. You can do the problems from that idea also, and it is a bit different to that of relative velocity. So today my aim is to give you the clear ideas about velocity of. Suppose there are two particles, say the particle 1 and particle 2, right? So, what will be the velocity of 1 with respect to 2? It can be, I will write a particle 1 having velocity v1 and particle 2 having velocity v2. Then I will say the relative velocity of 1 with respect to 2. Particle 1 with respect to particle 2 will be what V12 that you know, and this is equal to V1 vector minus. So this thing is very clear to you, and this will, if here V12 means the velocity of particle 1 means velocity of particle 1 as it is observed by the from the observer 2, or we can say the particle 2. Particle 2 we can consider as an observer also. So from this observer, he or finds the velocity of 1 is something v1 minus v2. v1 minus v2, if I say, it will be v1 and minus v2 is just this, something like that. So I can, let me draw with the different color. So this could be minus v2 and this is what v1 minus. So this vector is what relative velocity v12 as observed by this observer. This idea you have, and you know, but in some questions you will find that the two objects finally meet, and most common is the questions of collision. Collisions occur only when two objects meet at somewhere, right? And after that they separate. So whenever two objects collide, we can say there is a velocity of approach along the line joining the particles. So if two objects either collide or meet, then there must be velocity of approach along the line joining the particle. So what the difference? Here, if I take the velocity of 1 relative to 2, velocity of particle 1 with respect to particle 2, but along, this is important, along the line joining them. So if I am considering, or this is also known as line of sight, that we can say line. If I take the velocity of 1 with respect to 2 along the line of sight, so what it will be? Say this is 1 Velocity is v1. This angle is at theta 1. This is particle 1. This is particle 2. At some instant, its velocity is say v2. Say this angle is theta 2. So velocity of 1 along line of sight. Along line of sight. What is the velocity of 1 with respect to 2 along line of sight? That is, I can say velocity of 1 along line of sight minus velocity of 2 along line of sight. And this is nothing but v1 cos theta 1 minus v2 cos theta. Or I can say also v1 2 parallel, right? Why I named it parallel? Means parallel to what? Parallel to R12, position of 1. This is V1 2 parallel, right? This is the velocity parallel to line of sight. And R12, if I say that is the position of 1 with respect to 2. And this vector is this one. To be careful. This is R12 vector. This one is R12 vector and this one is V12 vector parallel to line of sight. Basically, if I say more clearly, it is like this. V12 parallel to line of sight, unit vector in that direction must be R12 unit vector. But how about the direction? These two are opposite to each other. So it is what? Minus sign. So you must remember this, right? So this is what the velocity of approach is, the velocity along line joining two particles. V12 parallel. This is the basically I named it. V12 parallel I should named it velocity of approach. Basically, this is V1 cos theta 1 minus V2 cos theta 2. One moment. Alright. So, students, so this is, I think, we approach is this. Basically, what I am telling you here, make it, see, this is 1. Again, I am drawing it like this. This is V1 and this is V2. And this angle is theta 2, this angle is theta 1. I said you this is the velocity of approach, means velocity of 1 with respect to 2 in parallel direction. 1 with respect to 2 in parallel direction. 1 with respect to 2. And this could be the velocity of 1 with respect to 2 in perpendicular direction. So basically the velocity of 2, velocity of 1 with respect to 2, I can say velocity of 1 with respect to 2 parallel to the line of sight plus velocity of 1 with respect to 2 perpendicular to line of sight, right? And you must know for collision to occur, right? Right? And if V12 vector is a constant vector, suppose V12 vector, if V12 vector is a constant vector, then V12 parallel perpendicular must be equal to what? 0. If it is not 0, then how they will collide? It will collide only when the velocity is only along the line of sight. Only along the line of sight. But if there is an accelerated motion, then even it will collide. If the velocity is in perpendicular direction also, means If the velocity of both the object is constant vector, then v12 must be along the line of sight and opposite to that. अगर यदि एक्सिलरेटेड होगा तो हो सकता है कि 1 यहाँ पे हो, 2 यहाँ पे हो इनिशियल मोमेंट, ये लाइन ऑफ साइट है, बाद में कहीं यहाँ पे जाके टक्कर हो गया, है या नहीं? So that is possible for accelerated motion. So what exactly V12 parallel, that is velocity of approach. Velocity of approach is nothing, but you can understand. If the velocity of approach, then the distance of 1 from 2 means what? R12. R12, position of 1 with respect to 2 as a function of time must decrease, yes or no? If V12 is in this direction, velocity approach is in this direction, then it must R12 mod. This mod must decrease with time because velocity approach is what? Opposite to that. So velocity approach is must be equal to what? D R12 mod by dt with minus sign. Why minus sign? That you understand. So this is what the velocity of approach we can say. Anyhow, this will be mod even we can say because this is always, let me write, uh, I can say this velocity approach is, this must be what? Minus of dr12 by dt means with time what will happen? This will decrease. dr12 by dt, this value will decrease. Let me write in a more, in a better way. What we can write, you know, if I can write further this thing, so what we can say? We can say d r12 vector mod of that is what? Minus e approach into dt. Yes or no? If I integrate it, what I will get? It is t. Suppose they meet, if they collide at time t is equal to capital T, say t equal to 0, these two particles are here. This is 1, this is 2, and this distance is, I am saying, r12 t equal to 0. And at some moment, it collide, maybe somewhere, it collide here. It collide here means 1 and 2 come here. Both the particles come to the same position. Means what? R12 R12 at time t is equal to t. R12 at time t is equal to t. This mod or even this vector is equal to what? 0. So at time t is equal to, let me say, t is equal to which t we are talking about basically here? T is equal to capital T. So t is equal to capital T. This is finally come, both 1 and 2 come at the same point. So collision took place and then their distance between them is 0. It means what? If I say this is at t0, the position is what? R12 t is equal to 0, I can say. T is equal to 0 mod. And then this will be what? R12 at t is equal to capital T. And this mod, and this is equal to what? B is equal to t to t is equal to t. So I can say R12 at t is equal to capital T at the time it collide, right? Minus R12 after integration we are putting the value upper limit minus lower limit and then t is equal to 0. That is equal to what? Minus t approach dt 0 to t. And we know when it collide or meet, What happened? R12 T is equal to T is equal to kya? 0. When the 0 means mod is also 0. So 0 minus at the initial moment R12 R12 at T is equal to 0. Whatever the distance between them, let me call it by L. L is the distance between them. Initial distance between them, right? So I can say 0 minus L is equal to 0 to T, velocity of approach into dt. And then I can write from here velocity of approach into dt 0 to T is equal to L. This is very useful concept. You can apply to many problems, friends, and this is quite useful, And if the magnitude of velocity of approach, anyhow, velocity of approach is always opposite to the R12 vector. So, but if velocity of approach, whatever the motion, maybe the motion of these two objects is in a straight line or it is in a curve, motion may have the acceleration relative motion, but when I am talking about velocity of approach, it is always opposite to R12. E12 parallel, that is approach, must be opposite to R12 vector. So that you got it. This idea is clear. But if that velocity approach is constant, means this approach is constant, right? It may be constant, may not be constant. If it is constant, then we can write velocity approach I take outside the integral. Integral dt will be t is equal to L. So this is for V approach varying. Means the velocity of the particle along the line of joining. You see this thing, once again I am telling you, this is initial moment L, this is the velocity approach V12 parallel some value, and after some time it could be like this L dash at time t, this is V12 parallel at time t. If this is changes, this is t equal to 0 maybe, right? If it is varying, this value is varying, this one, then we have to integrate. But what we will get after integration? We will get L. This is what we did here. So this is carefully you should understand. And then if it is a constant velocity of approach, that direction it is always constant, always opposite to R12. That you must understand, right? Here one, here two, here one, here two. This is R12. This is R12, right? As a function of time. So it is always opposite to R12. But if the magnitude of R velocity of approach is constant, right? Then we can take outside the integral and we can apply this formula. And if it is not constant, we can apply this. Let me take two problems to understand this thing clearly. First, let me take the problem of three friends is an corner of an equilateral triangle of take subside A. Let me draw it. So let these three friends A, B, and C at the corner of an equilateral triangle, and friend A at t is equal to 0, the friend A starts moving towards B, and B towards C, and C towards A. So all three start follow to next one like that. So what will happen, as A start follow B, B is going like that, so A will turn like this. So, and B will follow C, so B will turn like that. So A is turning like this, B is turning like this, and C is turning like this. And all three by symmetry, they will meet where? At the centroid of the triangle. Alright. So that is the things, And then if I try to do this question from relative velocity, oh, it's changing all the time. Angle is changing. Really difficult. then it's really difficult. You just think, I will take another lecture on relative velocity, and then you know, because here velocity of each one is u all the time. Speed of each one is u. I can say speed is u, right? How is the path of these three friends? A is going like that, B is going like this, and C is going right. They will meet at centroid. They move by symmetry. You know, at any instant of time, how will be this is at t is equal to 0. They are at said at t is equal to t. This is the t is equal to 0. They are here. But let A come here, B is here, and C is here at some time t. So what will happen? It will be something like that. Means again it will form the equilateral triangle, right? Because by symmetry we can say it will form the equilateral triangle, and then this will be what? This will be u. This is u, this is u, because speed is same, this is u, right? And if I try to do by relative velocity, it's a really cumbersome, it will be a complex. But let's see how good to do this problem by velocity of approach. Now, what is the velocity of approach? Velocity of approach. Let's consider friend A and B, right? So, velocity of approach of A with respect to B means velocity of approach, let me write. I am considering AB. Okay, friend A and friend B is what? Line of sight. This is line of sight. It is very clear. This is line of sight. Along line of sight, velocity of A along line of sight minus velocity of B along line of sight, and this is nothing but u minus its direction is opposite. This is 60 degrees, so this will be u cos 60. That is u by 2. So minus u by 2 since direction is opposite. It will be what? 3u by 2. So I got the velocity approach is what? 3u by 2. Alright. I have to check whether this velocity approach is constant in magnitude or is it varying. At some other instant, at time t, this is u, this is u, this is u. Again, this angle is 60 degree. So approach is what? U minus u cos 60, u minus minus of u cos 60. That we can 3u by 2, right? So some other instant also it will be what? This is u, this is u by 2. So at t is equal to t, this velocity, u velocity of approach is again what? U minus minus of u by 2, and that will be 3u by 2. Okay, I think it is right. Let me, one moment. One moment. So what you have seen, you know, the velocity approach at t equal to 0 or t is equal to t, it is constant in magnitude, and it is always opposite to line of sight. That you know, R12 I can say, right? It is in direction of line of sight and opposite to what? R12 means dBA, opposite to velocity of A with respect to B is dA minus velocity of approach is opposite to what? RAB. Opposite to what? RAB. Because this is what RAB. Already we have discussed this theory, right? Now, let us directly use the formula. Which formula you will apply here? Integration or without integration? So definitely without integration, since the magnitude of velocity of approach is constant 3u by 2, and then the problem is very simple. Velocity of approach into t is equal to what? Initial distance L. Here initial distance is given A, velocity of approach is 3u by 2 into t, so I got t is equal to a by. So after this time they will meet. So if I ask you what is the distance, basic questions, covered by any one friend till they meet. So that is again simple question. The speed of each friend is what? U continuously, right? So distance covered by A, if I say by A will be what? S is equal to U into T. And this will be what? U into 2A by 3. U. So U is out, so it will be 2A by 3. So this path length, it is a logarithmic spiral because or it's going like that. So finally, its radius is also changes, decreases, right? Radius decreases, angle increases, right? But this path, till it comes to the center, centroid, it will cover, each one will cover a distance 2A by 3. If I ask you, what the distance covered by the person A, till it turned an angle, say 2 pi or pi. So till it turned, it started from here, right? Say A is started from, B is started from here, and then it going like this, right? So more clear diagram is something like that. I can draw. Say A, B, and it goes like that and meets something like this. If I ask you, what is the so what is the distance covered by A or B till it covered an angle 180 degrees? So it started from here, B, and till it covered 180 degrees, what this point, right? So here to here, what the distance? So make this, I'm just making this to be a black one. So what will be this distance? I got the total distance. It's simple. Total distance for B, I got what? 2A by 3. Or A, I got 2A by 3. Or C, I got 2A by 3. But if I ask you how to find the distance covered when it turns to an angle 180 degree, a good question. But this again, the questions of kinematics. You should try. You should try with this idea that if I take this distance from centroid to this, right, then you should apply the concept of kinematics, right? And you can try it, you can do it. So you can take this value to be some instant, this you can take R, and you should take, the velocities along the R, that's opposite to R and perpendicular to R. And you can solve, but this problem of kinematics. So now let me focus on velocity approach. So this you can do, you should try, right? But here you got it. This question with the help of velocity approach. Let me do the another questions in which the velocity of approach, this magnitude is not constant. How you will do? If the magnitude of velocity of approach is not constant, how you will solve? Even these questions, you try it. Otherwise, I will solve. I will let you know, right? So this is nothing big at all. You should write. This will be u. I'm just giving you some hint. U. This angle you consider some theta at some instant of time. Take this to be d theta. Take a component of u perpendicular to that, and one is along r. So the component of u along r will be u parallel. I am saying d mod r by dt, and u perpendicular is what? R d theta by dt, r omega, right? You just try it with that. Will get it. But now my questions to you is how you will do the questions in which the magnitude of velocity approach is not constant. ऐसा सवाल हमें कहाँ मिलेगा? ये बहुत कॉमन क्वेश्चंस है. ऐसे तो क्वेश्चन वो एरोडॉप का क्वेश्चन है, लेकिन हम उसको टॉम जेरी के हिसाब से सॉल्व करते हैं. बहुत ही एग्जाम्पल लेते हैं. जैसे मान लीजिए यहाँ पे एक कैट टॉम है और यहाँ पे एक जेरी है और इसकी इनिशियल डिस्टेंस मान लीजिए एल है, ठीक है, और ये फेंस है. अब किसी मोमेंट एट टी इज इक्वल टू 0 पे टॉम का आमना सामना हो गया जेरी के साथ, टॉम और जेरी का। दोनों एक दूसरे को, दोनों की नजरें मिली। अब क्या होगा? जेरी को भागना और टॉम को फॉलो करना, पीछा करना। और जेरी के लिए कोई रास्ता है नहीं एक्सेप्ट कि वो अलोंग द फेंस जाए, क्योंकि वो ऐसे जाएगी तो टॉम विल कैच इन लेसर टाइम। और ये भी मान लीजिए कि टॉम की स्पीड कैपिटल भी है, वेलोसिटी ऑफ टॉम को भी बोल देता हूँ, एंड वेलोसिटी ऑफ जेरी को मैं यू बोल देता हूँ, एंड गिवन कि v की मैग्नीट्यूड u के मैग्नीट्यूड से ज्यादा है, सो इट विल। अब देखिए, इस सवाल में उसकी जो रिलेटिव वेलोसिटी है वो कंटिन्यूसली चेंज हो रहा है, राइट। इस क्वेश्चन को भी हम वेलोसिटी अप्रोच के कॉन्सेप्ट से करेंगे। क्या होगा आफ्टर सम टाइम जेरी एंड टॉम एंड जेरी विल मीट। So Jerry will go like this, and Tom will follow the Jerry all the moments. So they will go like this, and finally they will meet. Right. So they will meet something. So here Tom and Jerry will meet. Right. Now, so they will meet means I can apply the same concept, same formula you can say which we have derived. So this is at some moment of time. Here is Tom. So this is the moment at t is equal to 0. See, the velocity of Tom is v and velocity of Jerry is u. So velocity of approach is v minus 0 because the line of sight is this. So this along line of sight टॉप की वेलोसिटी v और जेडी की u, इसका कंपोनेंट along line of sight लेंगे cos 90 0 हो जाएगा। ठीक है, वेलोसिटी अप्रोच इज 0 at t is equal to 0. So velocity of approach at t is equal to 0 is v. Now what is the velocity approach at t is equal to t? यदि ये कांस्टेंट होगा तो हमें इंटीग्रेट नहीं करना होगा, चेक करते हैं। ये क्या है? v है। टॉम किसको फॉलो कर रहा है? जेडी को। तो जेडी कहाँ पे होगी? कहीं यहाँ पे होगी। यस। जेडी की स्पीड क्या है? u है। और ये जो टॉम की जो वेलोसिटी वेक्टर के साथ जेडी का एंगल है वो मान लेते हैं अल्फा है। अब देखिए, जो वेलोसिटी अप्रोच है वो क्या हो जाएगा? दिस इज लाइन ऑफ साइट, राइट। मैं लाइन ऑफ साइट को कलर से बनाता हूँ। ये लाइन ऑफ साइट, ये साइट वगैरह। तो ये लाइन ऑफ साइट अभी हो गया। अब देखिए, इस लाइन ऑफ साइट के लॉन्ग अलॉन्ग जो वेलोसिटी ऑफ टॉम है वो क्या है? v है। तो लेट मी राइट v। और जेडी की वेलोसिटी क्या है अलॉन्ग द लाइन ऑफ साइट? u का कंपोनेंट u क्रॉस अलॉन्ग लाइन ऑफ साइट। तो ये बात आपको समझ में आ गई वेलोसिटी डायरेक्शन। अब मुझे बताइए कि ये क्या कांस्टेंट है? क्या अल्फा सेम रहेगा? आपको समय के बाद यहाँ पे ऐसा हो जाएगा अल्फा। ये अल्फा तो चेंज हो रहा है। फाइनली अल्फा की वैल्यू क्या हो जाएगी? 0 हो जाएगी। शुरू में अल्फा की वैल्यू क्या थी? 90 डिग्री थी। तो भाई ये अल्फा तो कंटिन्यूसली चेंज हो रहा है और इसको इंटीग्रेट करना थोड़ा डिफिकल्ट टास्क है, बट हम लगाते हैं इसको। हम पहले तो कॉन्सेप्ट यूज करते हैं। क्या कॉन्सेप्ट यूज करना है हमें? वेलोसिटी ऑफ अप्रोच इनटू dt, velocity of approach into dt integral is equal to what? इनिशियल डिस्टेंस l। हमने ऑलरेडी डिराइव किया है, ये बहुत ही यूजफुल है क्योंकि हमने डिराइव किया। तो इट इज व्हाट? l। so I got this is equal to l, which is the initial distance, and the time of the meet is t। तो वेलोसिटी अप्रोच हमारा क्या आ गया? ये आ गया। तो मैं लिखूंगा एज ए फंक्शन ऑफ टाइम v माइनस यू कॉस अल्फा dt 0 to t is equal to l, and this is our equation number. All right. Now, how you will integrate it? Because here time is variable, alpha is changing, v and u are constant, so we cannot able to integrate. So here we have जैसे वेलोसिटी अप्रोच से तो हमने ये इक्वेशन बना लिया, लेकिन हमें एक इक्वेशन और चाहिए जिससे कि हम cos अल्फा को एलिमिनेट कर पाए। और उसके लिए जो बेस्ट पॉसिबल तरीका है वो तो कैनमेटिक्स यूज करना होगा आपको यहाँ पे, कि ये डिस्टेंस एक्स डिस्टेंस जो है दोनों के लिए सेम है। जितनी डिस्टेंस जेरी ने ट्रेवल किया एक्स में इन दिस डायरेक्शन, उतना ही डिस्टेंस एक्स कोऑर्डिनेट में मैं इसको एक्स और वाई बोल दूं कि दिस इज एक्स एंड दिस इज वाई, तो एक्स में दोनों की डिस्टेंस सेम है। तो एक्स में जो डिस्टेंस है उसको यदि मैं लिखूं एक्स इज इक्वल टू, जेरी के लिए क्या हो जाएगा? u इंटू टी के बाद मिल गया। टॉम के लिए क्या हो जाएगा? एट सम इंस्टेंट ऑफ टाइम इसकी वेलोसिटी v है, इसका एंगल इससे क्या अल्फा है, तो इसकी वेलोसिटी क्या हो गई इस डायरेक्शन में v cos अल्फा, एक्स डायरेक्शन में मैं क्या लिखूंगा v cos अल्फा, ये अल्फा वेरिएबल है तो हमें इंटीग्रेट करना पड़ेगा, इनटू दिस इंटीग्रेशन विल बी व्हाट x। तो यहां से हमें जो मिला कि इंटीग्रल 0 to t cos अल्फा dt, इसकी वैल्यू हमें मिल गई u अपॉन v बाई टी। इससे हमारा जो इंटीग्रेशन ये है, मेन इंटीग्रेशन में सॉल्व करना है, इसे हम सॉल्व करेंगे तो क्या हो जाएगा v इंटीग्रल dt 0 to t माइनस u 0 to t cos अल्फा dt इज इक्वल टू l, और ये हो जाएगा वी टी माइनस यू, इसकी वैल्यू पूरी की पूरी वैल्यू में मिल गई u बाई वी इंटू टी इज इक्वल टू एल। तो क्या हो जाएगा ये वी स्क्वायर माइनस यू स्क्वायर टी बाई वी इज इक्वल टू एल, तो टी इज इक्वल टू एल वी बाई वी स्क्वायर। आपने वो सवाल सॉल्व कर लिया जिसमें कि वेलोसिटी ऑफ अप्रोच जो है वो कांस्टेंट इन मैग्नीट्यूड नहीं है। क्या हम बहुत सारे मतलब क्वेश्चन क्वाइट ऑफन क्वेश्चंस आए हैं जेई एडवांस में, जो कि वेलोसिटी ऑफ अप्रोच से कर सकते हैं आप, क्योंकि कोलिजन हो रहा होता है, दो पार्टिकल्स का मोशन साइमल्टेनियसली दे हैव थ्रोन लाइक दैट, और प्रोजेक्टाइल मोशन वाले प्रॉब्लम भी होते हैं जिसमें कि दो ऑब्जेक्ट्स को अंडर एक्शन ऑफ ग्रेविटी फेंका जाता है। जब भी हम दो ऑब्जेक्ट्स को अंडर एक्शन ऑफ ग्रेविटी थ्रो करते हैं तो आप इस बात को समझ लीजिए कि उसकी रिलेटिव एक्सीलरेशन क्या होती है, जीरो हो जाती है, क्योंकि दोनों का एक्सीलरेशन क्या होता है अंडर ग्रेविटी टी होता है, नीचे की वाली में बोले तो माइनस डी होता है, तो दोनों की रिलेटिव एक्सीलरेशन क्या हो जाती है, वो जीरो हो जाती है। तो रिलेटिव एक्सीलरेशन क्या हो जाता है, जीरो हो जाता है। तो आप ऐसे क्वेश्चन मतलब जो वेलोसिटी ऑफ अप्रोच होगा वो अपोजिट टू r12 मतलब वो होगा कोलिजन के प्रॉब्लम में, और वेलोसिटी ऑफ अप्रोच से जो कंपोनेंट हमने परपेंडिकुलर लिया था वो हमेशा जीरो होगा यदि कोलिजन हो रहा है अंडर ग्रेविटी, और ऐसे प्रॉब्लम जिसमें कि एक्सीलरेशन नहीं है। जैसे मैं एग्जांपल लेता हूं, मैं एग्जांपल लेता हूं, जैसे मैं बोलूं कि सपोज मोशन अंडर ग्रेविटी का मैं एग्जांपल लेता हूं, जैसे मान लीजिए मैं कह रहा हूं कि एक ऑब्जेक्ट को हमने, एक ऑब्जेक्ट 1 है या ए है, इसको हमने 40√2 मीटर पर सेकेंड से थ्रो किया, ठीक है, कुछ एंगल थीटा से, और दूसरा ऑब्जेक्ट है जो कि जिसकी कोऑर्डिनेट है 0,120 मीटर, इसको हमने कुछ थ्रो किया 40 मीटर पर सेकेंड, ऑल राइट, अंडर एक्शन ऑफ ग्रेविटी, और ये कह रहा है कि if both the objects collide somewhere in air, so first of all you have to find what is the time of collision, after what time they will meet or collide। दोनों को t इक्वल टू 0 पे ही थ्रो किया गया, ठीक है ना, ठीक है, a एंड b को थ्रो किया गया। now how you will do, again I can say you can apply the concept of velocity of approach। So what is velocity of approach? Velocity along the line of sight. So what is the line of sight? This is the line of sight. So what is the velocity along the line of sight? ये कंपोनेंट 40√2 sin थीटा, इसकी ये कंपोनेंट 0, तो वेलोसिटी अप्रोच क्या हो जाएगा 40√2 sin थीटा माइनस 0, और इसकी वैल्यू क्या है, कांस्टेंट है फॉर गिवन थीटा, राइट, वेलोसिटी अप्रोच क्या होगी, कांस्टेंट हो जाएगी, क्योंकि एक्सीलरेशन ऑफ a विथ रिस्पेक्ट टू b की मैं बात करूं तो क्या हो जाएगा g वेक्टर माइनस g वेक्टर, एंड दैट इज इक्वल टू 0। तो ये एकदम बिल्कुल ऐसा सवाल है जो वेलोसिटी अप्रोच क्या कांस्टेंट है। तो टक्कर होने के लिए क्या होना चाहिए कि वेलोसिटी ऑफ अप्रोच v वेक्टर एज आई टोल्ड यू, बताया था मैंने अभी आपको, ये 1 है और ये 2 है। ये वेलोसिटी ऑफ 1 टू पैरेलल है और ये v1 टू परपेंडिकुलर है, ये लाइन ऑफ साइट से। तो v वेक्टर इज व्हाट, 1 टू पैरेलल प्लस v12 की बात मैं कर रहा हूं, प्लस v12 परपेंडिकुलर। Velocity of one with respect to relative velocity. What is relative velocity? Relative velocity will have two components, I can say. One is velocity of approach and other is a component of velocity of particle 1 with respect to 2 perpendicular to line of sight. So since they meet each other and velocity of approach is constant, then and there is no acceleration, then it is only possible that there is no perpendicular component. Means what? V12 perpendicular must be 0. It means what? Velocity of 1 in perpendicular direction minus velocity of 2 in perpendicular direction must be 0. So velocity of 1 in perpendicular direction must be equal to, I can say, velocity of 2 in perpendicular. So in this problem, what is the line of sight? This is the line of sight. So what is the velocity in perpendicular direction? That will be what? Its velocity is what? 40 root 2, first one. So I can say 40 root 2 cos theta must be equal to this velocity. Perpendicular direction क्या है? 40. मैंने क्या किया? This is V1 perpendicular is equal to V2 perpendicular. Yes or no? And then I got cos theta is what? 1 by root. And I put this value here. यहाँ मैंने ये यूज करूंगा वेलोसिटी ऑफ अप्रोच इनटू टाइम t इज इक्वल टू l, जो हमने फॉर्मूला डिराइव किया है। एंड दिस विल बी व्हाट, v approach will be, I got it 40 root 2 sin theta. So 40 root 2 sin theta into t is equal to 120. इसकी इनिशियल डिस्टेंस बिटवीन देम कितना है? 120. So I will get 40 root 2 40 root 2 sin theta की वैल्यू पुट कर दीजिए, 1 by root 2 into t is 120 and you got t is equal to 3 seconds. So after 3 seconds they will meet. Quite simple. Student, IIT भी ऐसे क्वेश्चंस बहुत ही फ्रीक्वेंट, ऐसा क्वाइट ऑफन पूछा है जिसमें कि वेलोसिटी अप्रोच हो, प्रोजेक्टाइल हो या फिर 2 डायमेंशनल मोशन हो। मैं जेई एडवांस 24 का क्वेश्चन बता रहा हूँ, पेपर 2 से क्वेश्चन जो कि सिमिलर क्वेश्चन अप्रोच से आप बना सकते हैं। एग्जांपल लेता हूँ। वो क्वेश्चन कुछ ऐसा है कि एक्स वाई प्लेन पे दो पार्टिकल को प्रोजेक्ट किया गया, हॉरिजॉन्टल प्लेन है, राइट। वन मोमेंट, एक्स वाई प्लेन है, एक पार्टिकल को ओरिजिन से प्रोजेक्ट किया गया एट एन एंगल थीटा, बॉल मान लिया, बॉल को प्रोजेक्ट किया गया विथ ए वेलोसिटी v नॉट एन एंगल थीटा। दूसरे स्टोन को प्रोजेक्ट किया गया हॉरिजॉन्टल ग्राउंड पे, कोई फ्रिक्शन की बात नहीं, हॉरिजॉन्टल ग्राउंड पे समझ रहे हैं, v1 से कोई फ्रिक्शन दिया नहीं है, v1 से, v1 या मैं v मान लेता हूँ, वेलोसिटी नहीं दी हुई, मान ली v से प्रोजेक्ट किया गया एट एन एंगल थीटा 1। Basically, angle is given 180 minus theta 1 from positive x-axis. So I have taken theta 1 in, right, from negative x-axis, right? तो ऐसे प्रोजेक्ट किया गया और ये कहा गया कि दोनों ऑब्जेक्ट कोलाइड होता है। मतलब अगेन द क्वेश्चन ऑफ वेलोसिटी अप्रोच से हम कर सकते हैं, दे कोलाइड एट टाइम t1. The question is given, they collide in time t1 if theta is 45 degree and theta 1 is also 40, and collide at time t2 if theta is 60 degree and theta 1 is 30 degree. So you have to find the value of t1 by t2 whole square. Okay. And given the initial distance between them is, some take L. Again it will be You can apply the velocity approach and you can do. So this is the line of sight, right? There is no acceleration, so velocity will not change. So velocity approach will be constant. So and since they collide also, so what will velocity approach? Velocity of approach will be since collide means I told you that perpendicular component is always zero. So V approach will be what? V naught cos theta minus V cos theta 1, right? And this will be your V naught. This is 45 degree in case 1 45 degree. Then velocity approach will be how much? V naught by root 2 plus V by. Now you know very well, as I said you there here only I think ये वाली जीरो होती है परपेंडिकुलर कंपोनेंट, राइट? दोनों की परपेंडिकुलर कंपोनेंट क्या होगी? दोनों ऑब्जेक्ट की परपेंडिकुलर टू लाइन ऑफ साइट क्या होगा? इक्वल होगा. इट सेड यू दिस थिंग वेरी क्लियरली. तो ही कोलिजन होगा. यदि एक्सीलरेटेड मोशन नहीं है तो, और ये एक्सीलरेटेड मोशन नहीं है तो इसकी जो कंपोनेंट होगी वेलोसिटी परपेंडिकुलर डायरेक्शन में वो क्या होगा? इक्वल होगा, मतलब परपेंडिकुलर टू लाइन ऑफ साइट. सो व्हाट इट विल बी आई कैन राइट V naught sin 45. First case it is 45, so this will be what? V naught sin 45 is equal to what? V sin 45. V naught sin 45 is equal to V sin 45. It means what? V equal to V naught, and I will put here, so I will get what? V naught plus V naught, 2 V naught by root 2 is root 2 V naught. And I apply the formula then, velocity of approach into T is equal to L. Achha, why no integration? Because no accelerated motion, velocity will not change, and collision is there. So in perpendicular direction also the velocity will be equal. So only velocity of approach is always along the line of sight. It is constant. There is no change in velocity, no acceleration. All right. So I can write what? Root 2 V naught into T is equal to L. And again the second one, what will apply case 2? When the angle is 60 degree and 30 degree. So velocity of approach will be what? That will be V naught cos 60. Cos 60 is 1 by 2, V naught 1 by 2 minus of minus. E cos 30, that will be root 3 by 2. So velocity of approach will be V naught plus root 3 V by 2. Now again you apply the same concept, perpendicular direction. This will be what? This is V naught sin 60, and this will be what? V sin 30. These two are equal. So what I will write? I will write V naught root 3 by 2 is equal to V by 2. So V is equal to root 3 V naught. So I will put this value, so I will get velocity of approach. In this case will be V naught plus root 3, or V is equal to root 3 V naught. Again I can write root 3 V naught by 2. So it will be what? 4 V naught by 2. So again I will apply the same formula, velocity approach into time t2. Here I have to write time t1 given is equal to what? L. So I can say 2 V naught into T2 is equal to L. This is equation number 2. This is equation number 1. Divide 2 by 1. Equation 1 by equation 2. Let's write. So it will be what? Root 2 V naught T1 by 2 V naught T2 is equal to L by L. And then this will be, this is out. So T1 by T2 is equal to root 2 and T1 by T2 square is equal. तो आपने क्या क्या बातें समझे बच्चों? ये 2024 के क्वेश्चन हैं जेईई एडवांस का. आप क्या क्या बात समझ में आपको आ गया? आपको जो बात समझ में आया मैं थोड़ा ब्रीफ कर देता हूं. वेलोसिटी ऑफ अप्रोच होता क्या है? दैट विल बी dr12 mod बाई dt. क्या चेंज होता है जो अप्रोच होता है? उस दोनों के बीच का डिस्टेंस. और माइनस साइन मैंने क्यों लगाया? क्योंकि वो हमेशा आपका V12 velocity approach this must be equal to R12 minus I unit vector, right? तो दूसरी बात मैंने क्या बताया आपको, जो आपको यू शुड मस्ट रिमेंबर, दिस इज 1, दिस इज 2, this is the velocity of 1, this is velocity of 2, whatever, but this is the velocity of 1 with respect to 2 parallel, and this is the velocity of 1 with respect to 2 perpendicular. Then I can say velocity of 1 with respect to 2 is velocity of 1 with respect to 2 parallel plus velocity of 1 with respect to 2 perpendicular. 2 parallel perpendicular is line of sight. This is I call velocity of approach plus velocity of 1 with respect to 2 perpendicular. So what I am telling you that if acceleration is 0, then for collision V12 perpendicular must be 0. Yes or no? And V12 should be equal to V approach. And then it means from here we got that velocity of 1 in perpendicular direction must be equal to velocity of 2 in perpendicular direction. Right? We can say this. And also in vector form also it is true. Right? So this we can apply, and if acceleration is not constant, not 0, even though we can apply what velocity of approach will change in magnitude. Suppose then integral dt is equal to what? R12 T0, and इसकी वैल्यू मैंने क्या बोला था? L, जो भी वैल्यू. So this is important, students. Velocity approach into dt 0 to t. If they meet after time t, then this is equal to L. और यदि वेलोसिटी अप्रोच की मैग्नीट्यूड कांस्टेंट है तो हम डायरेक्ट क्या लिखते हैं? वेलोसिटी अप्रोच इनटू टी इज इक्वल टू एल, जो कि इंटीग्रेशन से बाहर हो गया. आई होप यू गॉट द आइडिया, क्लियर आइडिया अबाउट वेलोसिटी ऑफ अप्रोच. वेलोसिटी अप्रोच क्या करता है? डिस्टेंस कम करता है, और जब फाइनली मिल जाता है दोनों तो उसकी डिस्टेंस क्या जाती है? 0 जाती है. वेलोसिटी अप्रोच नहीं होगा 1 और 2 के बीच में तो डिस्टेंस कम नहीं होगा. यदि मैं कहूं यूनिफॉर्म सर्कुलर मोशन और सर्कुलर मोशन, तो उसमें दो पार्टिकल यदि सर्कुलर मोशन में है और डायमेट्रिकली अपोजिट है, मान लीजिए दो पार्टिकल डायमेट्रिकली अपोजिट है. वन मोमेंट, ये 1 है, ये 2 है, इसकी स्पीड u है, इसकी स्पीड भी u है. राइट? अब मुझे बताइए वेलोसिटी ऑफ अप्रोच ऑफ 1 विद रिस्पेक्ट टू 2 दे आर मूविंग इन सर्कुलर पाथ पैरेलल मींस व्हाट? ये है लाइन ऑफ साइट, राइट? LOS. क्या होगा? दैट इज इक्वल टू द डिस्टेंस बिटवीन देम. समटाइम इट विल कम हियर, इट विल कम हियर. यस और नो? उसके बीच का डिस्टेंस कम हो रहा है क्या? R12 की मैग्नीट्यूड चेंज हो रही है क्या? R12 की मैग्नीट्यूड कितनी है? 2R है, रेडियस के बराबर होगा या नहीं? क्या इसकी मैग्नीट्यूड चेंज हो रही है क्या? नहीं. ऑलवेज डिस्टेंस बिटवीन 1 and 2 is 2R. So what will be D12 parallel? That will be dr12 by dt. Yes or no? Minus sign. And then this is constant. So this is equal to 0. So velocity of approach is what? 0. No velocity approach. Only there is a velocity of 1 with respect to 2. Even I can say yes, this is u. One moment. This is u and this is u, right? So below there is a angular velocity, yes. Omega, you know what is the difference? Omega of 1 with respect to 2 will be what? Velocity of 1 with respect to 2 upon distance R12. What? And that I can say u minus u, 2u upon 2r, and that is u upon r. So what I am telling you, because what is this? V12 perpendicular. V12 perpendicular is responsible for revolution, rotation, and V12 parallel along the line of sight, along the line dividing, is responsible for change in radius vector, change in the magnitude of radius vector. And then in some problem you may find the radius is also changing and angle is also changing, then the path is not circle, it is a spiral. And in case of a spiral path, we generally use what? Polar coordinates for solving the problem of kinematics. Generally, it is not expected in JEE Advanced up to that, but yes, little bit we will discuss about the polar coordinates and how we apply the kinematical problems in polar coordinates. That I will discuss, because in polar coordinates, you should know if r is also changing, then the acceleration of the particle is not simply, minus omega square r vector plus alpha cross r. It is not like that. It is different. So that I will take a separate lectures for in which r is changing and theta is also changing, right? Thank you very much, students. I hope you got the ideas about the velocity approach and how you can apply in the problems of JEE problems or competitive examination problems, or the problems you interact with, right? You can apply in most of the problem or all the problems in which the objects collide. So you can apply and you can get in a simple way. Even in some cases when there is a relative acceleration between the two particles, then to solve the problem with the help of relative motion is bit difficult, but with help of velocity approach it is quite easy. So you should understand the difference between velocity approach and relative velocity and how to use and where to use. That is important. I hope you got the idea. Thank you for watching.